one of the obvious ways to deal with a lot of the problems about video playback is to buffer the video in memory first, and right away it's in contention with other things happening in memory, other things the app is doing. In particular, I wanted to describe this experiment. I sat down and tried to make initialize as many concurrent video players as I could to see what things would fall over. And on Android, there's a particular problem with limited memory pools for audio tracks. Anyway, it's something worth doing in whatever your playback environment is. See how you do with concurrent decoders. So basic things for instrumentation. Maybe not as easy as say, look, latency, by which I mean from the moment a start signal, a playback signal arrives until the first frame is rendered, and so somehow you have to hook into the 2D graphics VSync one way or another. Measure buffering delays, meaning when playback is interrupted because of an underflow in the stream buffer, and how often does it happen and for how long. Any kind of error conditions, of course. Dropped frames or audio underruns, meaning starved for audio data. And then, of course, in adaptive bit rates, you want to know about track selection changes because this affects the user experience and the compression. OK, so that's instrumentation. Stream buffering is a really interesting problem where I've put a lot of my attention because of this range of APIs, depending on how old the phone is. The simplest APIs are automatic, and you can't, that is to say, like a video element in HTML5, you give it a source URL, and you maybe give it a preload attribute, and then you just hope for the best. And that's terrible, and you don't get to see and you don't get to control. There are better APIs where you get to specify things like a high or low watermark, like I wish to buffer until I reach this threshold, and then I wish to draw down through playback until I reach this threshold, and then I want to read some more from the network, and high and low watermarks. Also, all video players have headroom thresholds and amount of stream in advance in terms of presentation time, like 5 seconds that they want to have before they'll even agree to play for you. And you need to be able to tune that so that you can have a small buffer but still begin promptly. And then the best APIs actually give you a file-like interface to inject your video stream, meaning that everything about how it is buffered is under your control. So this is like a kind of pseudocode for a pattern on Android called a data source for video playback. A data source is some file-like interface. File-like means it has read and it has seek. And then you inject this into your player, and so when it wants data from some random access somewhere in the stream, it goes to you, and you get to try to guess ahead of time what it's going to want and how much safety margin to have for that, and make your trade-offs between memory and network and promptness and reliability. So this permits precise pre-caching, persistent caches. So like you can spill onto a file system if you want, if you like have things there between app instances or whatever. And layered buffering strategies. So fallback, in the usual sense of caching, trading off latency for availability and so on. I want to say this about start latency and stream buffering. This is just a piece of data. I'm not being precise, but I have experience to offer. You can buffer the whole video stream in memory, but you have two ways to do that. You can just have regular raw memory, and then you wait until you need it to fire up a video player, to call prepare or whatever is the initialization method on it. Or you can do all that prepare up front too, and actually feed the video into the player and have it initialize decoders and do, I'm not sure, whatever else happens under the hood, like loading dynamic libraries or other stuff. Anyway, the difference between these two designs is hundreds of milliseconds in video start latency on typical phones today. And so the last technique is careful control of video encoding. This is like an eye chart slide. What I'm really trying to say here is that the platform vendors, will tell you all about what their devices are capable of decoding, but there's a lot of interesting little details in it. And certainly there's people in this audience, I'm sure, are much more qualified than I am to talk about this, so I don't want to embarrass myself further. But I want to say that I want to point out there are, see these little API number blah blahs? There's a lot of dependencies there, so that what is, at a high level, you know that capabilities vary by how old the phone is. And then there's a lot of fine print. The stuff about metadata structure in MP4 is probably well known here, but there's a huge penalty if you put this piece of metadata at this point in the file versus that point in the file. It's very important to maintain, to bound the maximum separation and presentation time between audio and video samples for cache efficiency in the CPU. And there's lots of advice about adaptivity, like be sure to provide low bit rates for cell networks and don't have segment durations that are too long, and advice about iframes and that sort of thing. Anyway, all this stuff is critical. That's all I'm saying at this point. So here's something useful. Both Android and iOS offer what I call video capability APIs. So you can actually ask the operating system, can you decode MP4? Can you decode WebM? What is the maximum resolution that you support? What is the maximum bit rate that you support? What is the maximum frame rate? And so on. How many concurrent players can I make? And so on Android, I know Android much better than iOS. I apologize. API 16 introduced this, what they call media codec info, that gave you information, but it wasn't video specific. API 23, which is like 2015 vintage, gave you specifically video capabilities, where this little code snippet is an example. Here's the expert advice I want to offer about this. I don't trust it. So the implementation of these depends on two things. One is that the person who wrote the device driver needs to have read this, understood this API, and given data that is meaningful. And then the actual parameters where some particular hardware decoder falls over are not so clearly defined in terms of the parameters of this API. And so when I've done, have gotten some data, specifically trying to use VP9 on some particular Google product, and I'm not convinced that this API is accurate. So you got to have another way to find out what's really possible. Anecdotally, most devices that nominally support VP9, meaning anything on Android API 19 or above, they do not declare VP9 support in the capabilities API, so that the documentation is out of whack with the API response in the field. This is the real problem, fragmentation. These APIs evolve over time, and you have to decide what you're going to be compatible with, and they all affect your ability to perform the basic techniques. To the left is a pie chart diagram of the various versions of Android. This is like last week. And on the right is for iOS. Apple has always been better at their operating system software updates. Of course, Android has been burdened by relying on carriers to control this, and the carriers don't care about software updates by and large. So the Android picture is always more complicated. This is just a list of the basic important milestones from my point of view in Android video APIs. There has been a video player since the very beginning, Video View. And there was another one called Media Player. I'll tell you the differences. But it wasn't for at least 5 years until there were any significant updates to that. And then there's been a cadence since. API 16 is the big turning point where they exposed lower level internals, gave you a really difficult API on top of which really flexible stuff could be written. And so I want to make a plug for this project called Exoplayer. I think anybody here who's written a video app for Android probably knows about it. The point is, Exoplayer is a library that uses these media codec, media extractor APIs to make something interesting and useful that you can link with your app and deploy with your app, and you are no longer bound to software updates from people's carriers. So it updates with your app, not with the OS. This is a painful picture of the fragmentation problem from Wikipedia. The horizontal axis is time. It starts on the left from 2009 and goes all the way up to the middle of 2017. Each color is a different API version of Android, and you see how new versions are coming up and old versions are expiring, but any moment in time is a vertical slice. This is just the same data by year, but I have this in case I'm using an API number and somebody asks me a question. Here's my shamefully minimal knowledge about the corresponding API history on iOS. There is something called VPlayer, and then there's something, ironically, the later one is easier to use, but is a singleton. The easier iOS 9 API MP Movie Player controller. I haven't tried this, but my understanding is that if you accidentally make 2 of those, you will be disappointed. So here's the simplest way to play a video on Android. You say player gets new video view. That's the view. It's in your layout. You give it a URL, which is this is my video stream, and you say start, and it works. But you don't get to control stream buffering. You don't even get to see stream buffering. It doesn't understand any adaptive protocols. There's no instrumentation at all. You can tell that it started, but you can't tell how long it took. There's no way to release it. So you understand, like, if you want to control the number of decoders you're using, it's very important that when you're done playing, you release the decoder. Here, it relies upon garbage collection, and that depends on memory pressure. So if you're just making, want to have an app that plays a video and then plays another video, that may not work. But it does provide its own buttons, in case you didn't want to make a button. A better one, here's a better one. This is like what you could do in 2012 with the Jellybean release. You can make a media player. It has an injectable data source, which is file-like, and then you can call prepare. Then you say set surface, which is cool. So you get to hand it the producer of frame buffers, and so then you get to actually have a callback for each frame. And so you can monitor frame rate, and you can tell dropped frames. And that's all cool, but it still doesn't understand adaptive protocols at all, and it still has the problem of fragmentation, meaning software updates are controlled by the carrier. So this is how Exoplayer works. The code is incomprehensible because it has a lot of words in it that who knows what they mean. But then it is an open source app. You can deploy it with your app. It does understand HLS and smooth streaming, the adaptive protocols. It has DRM features. It is extensible and very well exposed, and the people who work on it are very communicative, and has thorough listener callbacks to understand pretty much everything you would want to know about how things are going. So I want to say one word quickly about mobile web video. I haven't really talked about that. I've been talking about platform APIs. So the important thing about mobile web video is the line at the bottom. There is no way to control stream buffering or observe its progress that I know of. Please correct me, but I don't know a way to do it other than media source extensions, which is an API that's like 3 years old and only exists on Android. I don't think iOS, that mobile Safari will do that for you. So you really just shouldn't do it. But it's very attractive, of course, because people know how to do things on the web, and the platforms have good support for taking like a web view and putting it into an app so that you can implement your app in JavaScript, but the playback will suck. Historically, the reason on Android, who remembers this? Android was heavily invested in Flash as the video playback solution up until like 2012. Anyway, it was not a good design choice, but so it meant it was behind in the HTML5 standard for a long time. You will find a lot of Android phones today that don't have HTML5. And so the critical point for mobile web video on Android is that the support begins at API 21, which is called Lollipop from 2015, where finally Google had the idea to make the web view update independently of the operating system. So even if you have a Samsung phone from Verizon or something like that, you can still Google will be able to update your HTML5 video features even if Verizon won't. And then the iOS hassles. So I'm not an expert of this, but in iOS web video, you can't autoplay without a user gesture, and even then it will only play muted. In iOS 9 and earlier, if you try to play video in a web context, it will only play full screen. And then those policies are, I guess, anyway, those are the basic warnings. So last slide. I want to just share with you what I'm currently working on. I work in advertising now. We have a product called native video ads. You know, on Facebook or Twitter, you scroll and there's a video comes into the screen and then goes off. We offer that as a syndicated ad product. So if you have an ad that has a scrollable model, a news feed of some kind, you can put videos in there. And so what I make is the SDK, the library which you as an app developer link to get this to happen. So I'm trying to make video playback in this context where I don't have any global control over resources. The app itself could be doing anything, including playing video itself, but I have to make my video work when the time comes. Second, I have no way to know when or if video will even start, because the developer says I want an ad, but the user may never scroll it on screen. And then when they scroll off screen, because this is an advertising API, it's not designed with video in mind, nobody ever calls release on my thing, so I have to be smart in guessing when I can destroy stuff. And so the one piece of good news is that since it's an ad, I pick the video. So I can cache it whenever I want, even yesterday, and it still works. Thank you very much. If it is actively declared as a capability, then I think the question is the parameters of the encoding, the bit rate and the resolution mainly. So here's what I would advise. What I want to do is find a way to do a little experiment. That is to say, I don't think it's any substitute for data, and I think anybody who wants to do this has to build their own database of devices. But for sure can explode in your face, and so what I would do is write a little test explosion and somehow get that on the device and try it out and make sure it's not using software decoding and have it be a sample of whatever you really want to deploy. And I have no other solution. Well, it's incremental, right? I mean, you might be really confident about certain popular devices. Like, I mean, for sure, we at Google, we have big labs of devices. You know, we have automated ways of doing this. You know, it's like you're pushing. All of this is about pushing into a long tail. So it's a question of how far you want to go.
Is that database like open, maybe? Because
Sorry?
you guys make Android? Because you guys make Android, could you maybe make that database like, I don't know, shared a little bit?
You know,
Tiny little bit? Tiny little bit of sharing.
things at Google are either open source or they're a big secret, and that's still a big secret.
It's like whether or not my Android device supports VP9 is right now a Google secret.
Your device?
Yeah.
You don't go to authority for that. You know, get your device and profile it. Like, you can do it. You can. Thank you very much, Matt.